Hello everyone and welcome to my new video. And what is this video about? Well, this week on Instagram I posted a video to a patch that I've been playing around with this week, and here it is. It's this sort of audio visual beats thingy, and apparently it made someone's dog go nuts. This isn't actually the first time I've had a comment about someone's dog. I'm wondering if maybe I'm not tapping into a gap in the market. Maybe I should start making music for dogs to lose their shit to. Anyway, so this video got 241 likes, which is quite a lot for me. Anyway, so I thought that I would try and make the patch again from scratch. Basically what it is a large selection of objects rendered using jit.gl.multiple, which are then being displaced using jit.catch, which is listening to audio, and then like some other bits. And then I did a bit of MSP stuff. So let's do that. Let's just do that right now. Let's make a jit.gl.multiple. And I want to have three params, access to three params, and I want those params to be at GL params. Position, scale, and color. Color spelled the American way. And then I'm going to put that into a jit.gl.grid shape with a shape at shape cube. That's all really I need for now. So we're rendering a cube. But when I connect the multiple, that cube's going to disappear because jit.gl.multiple needs some matrices to render multiple instances of this one grid shape. Now, normally when I've done stuff with multiple in the past, I've done it all in gen, but it occurred to me that actually you don't really need to write a gen patch to say that you want a sphere or a a cube. When you need a curb. So you can actually use a jit.gl.grid shape matrix with the matrix output, because it's essentially the same thing. So I'm going to say, I'm going to make a jit.gl.grid shape at shape plane at dim 100 by 100 at matrix output 1. So rather than that rendering to the jit.world, it's actually now a matrix. So if I make a P window here and connect that to the P window, those are the matrix. That's a matrix of a plane. So I'm going to connect that. Well, actually, first I'm going to make a matrix for my scale. So I'm going to make a jit.matrix here. It's going to be 3 planes, I think. Let's see. Float 32. Whoops. Float 32, dim 100 by 100. I don't think it needs to be 100 by 100. Let's do it this way anyway. And then let's have another one here. And then I'm going to make a pack set all 0. Plug that into my matrix for both of these. And then I'm going to make a float. Put that float in there. And then get another one here. Oh, why don't I zoom in a little bit? Okay. And then I need to take take this, I think. No, that goes in there. So we need to bang our matrix. That goes in there. That connects in there. So now I connect that. That's going to be my position matrix. This is going to be my scale matrix. And this is going to be my color matrix. So if I set these all to 1 and bring the scale up a little bit. There we go. Right. So actually what I've got now is a plane of cubes. So they are all huge. So let's maybe make them smaller. We need a very, very small amount of scale here so that we can sort of see that they are indeed loads of cubes. Okay, that's great. So yeah, we've got a plane of cubes. If I was to turn my grid on, if I was to go to the grid shape and change the shape, we could, for example, say have a sphere of cubes. Look at that. They are cubes. Or we could indeed have a sphere of spheres. Let's change this to spheres. There we go. We've got a sphere of spheres. Or we could have a sphere of donuts. Okay, if we make this a little bit bigger, we can see that they are donuts. Just about. It's quite hard to see. Trust me, they're the donuts. Anyway, I want to go with cubes. I want a plane of cubes. No, sorry. plane of cubes. Cubes, there we go. Right. So I can increase the position if I want by simply using a jit.multiply and a float for their position. So I can increase that. Why hasn't that worked? Oh. Let's try this. Ah, there we go. That's better. Yeah, okay. So now I can actually kind of make them take up more space. Or I can make them take less space. So I can make them, you know, this sort of thing. Anyway. Okay, so we've got a plane of cubes. That's all good. So, what now? Yeah, okay, now we need to do the audio analysis. So, zoom out a bit. Let's move all of this over here a bit. Okay, let's maybe label some of this stuff. So let's say this one could be comment space. Not really a great explanation. This one is scale. And this one is, but this one is color. And actually, I'm going to change that later. We're going to color it slightly differently. Anyway, now we need to do some audio analysis. Let's get jit.catch in, and we're going to use mode 3. Mode 3 kind of works like a sort of oscilloscope. It kind of takes a very fixed measurement of a frequency or whatever's happening in the audio and gives you like a good kind of steady matrix. So I'll just make a jit.p window here, and I'll create a cycle that's going at something like 300 hertz. We need to easy DAC to turn on the audio. And let's see that that is working. I won't do any audio yet. Right, that's working. Let's connect that into the jit.catch, and then let's take the render bang from the jit.world. And there we have a matrix of roughly 300 hertz. So if I change that to something like 400, then we get more. And if we go all the way up like that, we get this. If I swap that out, maybe with something like a noise, let's see what a noise does, then we'll just get that. It's all lovely stuff. So let's start with the cycle at, put it back to 300 hertz. Okay, so I am going to use this matrix to display this grid of cubes here only on the Z axis. Now, we can do that very simply over here by putting in a jit.op at op pass, so pass the X axis, pass the Y axis, and plus for the Z axis. So this now means that we can effectively displace the Z axis of our plane here with another matrix. So let's do it with the matrix from this catch. Actually, before we do that, let's just format it. Let's put it into a jit.matrix 3 planes float 30 to 100 dims 100 by 100. And let's plug that into the second inlet of the jit.op. And there we go. There is our deformed plane of cubes being deformed by the frequency of our oscillator. So if I increase that, we're going to get more. And if I decrease that, then we just get 1, 2, 3, 4 waves like that. But I don't really like how that looks. So I'm going to write a tiny, tiny little gen algorithm to convert that into something that I find a little bit more interesting. I'm going to make a jit.gen. I'm going to double click it. Go in here, and this is incredibly simple. All I'm going to do is create a S norm to give me the signed normalized coordinates of the input matrix, and then look for the length. Now, the length returns the length of a vector. Easily explained visually. So let's make 2 outputs for our little gen patch here. Right, so that is what the length is giving us. This is the signed normalized coordinates of the input matrix. So we've got 3 planes, red, green, and blue. And they go from -1 on this side, which is effectively negative black, up to red on the x-axis, green on the y-axis, and then on the z-axis, or the third plane, would be blue. But because the red and the green are summed together, we get yellow. Now, if that was normalized, then it would be from 0 to 1. So we would get actually 0 here, 1 here, 0 here, 1 here, 0 here, 1 here. But we don't want that. Let's go back in, put this back to S norm. And so what the length does is that it, well, it says here that it returns the length of a vector. But actually, in this case, what it's doing is that it's giving, the way that I'm understanding it is that it's giving us a value of 0 in the middle and a value of 1 all the way from the center to the outside. All right. So we've just got this black dot in the middle of a white thing. Right. So I'm going to use that. Let's get rid of this. I'm going to sample the incoming matrix by the length of the signed normalized coordinates of another matrix, just a blank matrix. And then what we get is this. We get a kind of dartboard of waves. So now if I use that to displace the z-axis on this plane of cubes, we get this. Look at that. Doesn't that look cool? Right. Quick celebration beer guzzle. And indeed, if I make a live gain here, live.gain, and plug my oscillator into the live.gain, and then out of the live.gain into the speaker, which should be connected to my audio interface. Can you hear that? Where's that coming from? Yeah, that one. Okay. So if I change the frequency, you can see it's going to change the shape. I'm really low down. Lovely stuff. So we can do some other things. Let's try and actually use this matrix here to define the color of all of these cubes. Let's see if that's worked. Yes, it's worked. So now if we have black in the matrix, we get black cubes. And if we have white, then we have white ones. So it just looks, oh, even that looks kind of cool. So I think this looks better because it sort of looks like a speaker, you know, and people can relate to the idea of seeing speakers flex from frequencies and stuff like that. So, okay, let's see what else we can do. Let's maybe make a little sort of sound sequencer thing, see if we can get it to animate a little bit according to sound. We're making an audio reactive mega patch. Okay, let's do that. Okay, so let's maybe make some sort of little audio sequencer thing. Let's get rid of that. Let's see what I can come up with. Let's move all this over here. So this is all our audio, or rather all our visual jitter and GL stuff, and then we'll do some audio over here. So we could just start with, maybe what I'll do is I'll make a, well, first of all, I'm going to make a phaser, which is going at, let's say, 1N at lock 1. Let's make a transport up here with a toggle for the transport and maybe a little thing for our tempo. And then I'll make a live scope and connect that there, turn that on. And now we've got a ramp going from 0 to 1 over the course of a bar at 120 BPM. And I'm going to use that to, I'm going to take another phaser, 16, going at 16th notes, locked to the transport. And I'm going to make a, I'm going to try and make a quick, like gen tilde patch, gen, and let's go in here. We've got our flux capacitor there, our empty gen patch. So I'm going to get rid of this. Okay, I'm going to have to think. Well, first of all, I'm going to make a noise here, and then I'm going to create a latch. I'm going to take the absolute value of the noise, and that is going to go into input to sample and allow input. Okay, so that's going to go into that side of the latch, and then I'm going to use the 16th note phaser to trigger that. So let's plug that into the second inlet of this gen patch, And yeah, maybe we can use delta. Let's see if this works. Put that in there and then put that in there. And no, doesn't work. Okay. Just got a load of noise. What have I done wrong? Let's ditch delta. No. Okay, so that is the allow input when non-zero. Okay, let's try greater. Oh no, let's try less than 0.5. No. I'm trying to build a sample and hold in Gen from like without any knowledge of how to do it. Input to sample. Bollocks to it. Okay, we won't use Gen. We'll just use, we'll do it outside. We'll do a noise here. We'll make take the absolute value of that, and then we'll run that into an SAH sample and hold. Initial trigger value 0 at trigger mode 6, which I'm never 100% convinced is working as I'm expecting. Anyway, let's see if we can make a sample and hold with that. Okay, so you get these interesting little kinks along the way, but, you know, that's kind of fine. All right, let's multiply this by, I was going to say 4. And then round that to 1 and see what we get. Got a Discord notification. Let's just mute that. I'm going for a very relaxed, informal approach with this video. It's Saturday night. I'm very tired. I've had a busy week. Not going to aggressively edit this video. Right. So we've now got a kind of, yeah, that's kind of looking okay to me. I'm just going to add 1. So I want to have some numbers going from like 1 to, well, actually it says 1 to 5. Okay, let's multiply it by 3 then. Okay, so now I'm going to make a selector. I'm going to have 4 inputs, and I'm going to use this little sample and hold patch to select random inputs of this selector. So we could start with this oscillator, which is going at, let's just put it back to 300 hertz. That can go into our live gain here, and we'll use that to create a selection. And then sometime, there we go. Okay, that's clicky, but that's all right because selector now has this really nifty ramp time attribute. So, and I think it's in milliseconds. So I can say sort of, yeah, we can kind of fade between the different inputs, which is really cool. So let's just make a noise thing here, and that can just go to input 2. Yeah. Maybe it's a bit loud. Let's just have another cycle here. This one could go at like 600 or something. Okay, this is obviously some of my best work. What can we have for the 4th? Let's have another cycle, but at 100 hertz. Oh no, 150. Well, not 15, 150. Okay, let's now plug this into the jit.catch. Okay. So obviously you can run in any audio you want. I just thought these sine waves, like there's a very clear audio-visual distinction between the two because we associate sine waves with curves and stuff like that. And this obviously looks very curvy. Lower frequencies have less curves or waves. Higher frequencies have more, and the noise is just indistinguishable. So we've got our, I want to maybe do like a little bit of amplitude shaping. So let's maybe take a multiply here, and let's try and make like a little sort of amplitude envelope trigger thing with the same phaser. So this is when I'm going to try delta. Let's try delta. Let's try delta live scope so I can see what that's doing. Right, that's giving me 16th note triggers. That's very nice, but I want them all in the positive range. Okay, great. Now let's put in a slide. Let's slide by 0 and then something like, well, let's to start with, say 5,000 samples. All right, already we've got a nice little curve there. And we actually want to take that and put that into our catch. So now it's going to start flashing. This is flashing. There will be flashing images, people. If you're sensitive to those things, you should know that now. Let's use the same sample and hold here to change that envelope time so that we can have some longer decay envelopes. So let's maybe like multiply this by, well, actually first let's do ms to samps. Is that a signal? Does that work with signals? I think it does. Okay, so let's multiply. What have we got here? Yeah, let's multiply this sample and hold output by, let's multiply it by 5,000. That will then get converted to samples, which is what the slide object is expecting. So if I plug that now into the, so you can see that we're getting different decay times modulated by our 16th note sample and hold. Let's see what. Okay, 5,000 is a bit much. Let's try 1,000. Okay, that's still a little bit much. Let's try 500. And then let's do the same. Let's do the same for the ramp time. So let's take a snapshot here every one millisecond or something, and put that into. Nope, not that one. This one. Put that in there. And then we can kind of modulate the ramp time of the selector, which I think is one of the coolest things that's been added to Max in recent versions, is being able to slide, interpolate between all the inputs. I love it. All right, so there we go. We've got our... And we can make this a little bit bigger if we want with the scale like that. Yeah. Okay, let's turn that down a little bit. Okay, so now what I want to do is, all right, so we've got our jitter and our OpenGL, you know, rendering thing. We've got our audio and they are talking to each other and having a very nice time. So what I want to do now is I want to look at some post-processing. And again, I've got to kind of remember how to do this. I did it the other day and then I didn't really take note of it. Actually, I've just seen I don't need that anymore. Let's get rid of that. So I'm going to, yeah, okay. So I'm going to name the world. I'm going to call the world the world. Jit.world the world. All right. Now we've kind of reinstantiated our world. Okay, let's actually connect that to the output of our live gain so that when I turn it down, it's nothing. Okay, so I'm going to put all of this now into a node. I'm going to create a node here, jit.gl.node, and the name, well, actually, I'm going to tell it to render to the world, but I'm going to give it a name, @name the node. So I'm going to tell these things here. I think I maybe only just need to do this last grid shape. Let's see. Let's tell the grid shape to render to the node. Okay, so the node, now I need to tell the node to start capturing the scene. So let's say @capture1, and let's connect that to a jit.gl.video plane @transform reset 2 and see if that is working. No, it hasn't. Oh, that's because I'm not sending it. No, it didn't work. Didn't work. Maybe I need to do it for this one too. Let's say the node. Yes. Yes. Sweet. Okay, so I think I'm now rendering to this node. In fact, let's say, so that's going to the world. That's interesting. Let's give this one a name as well. The rendering destination, the world. So the world is the final destination. The node is the sub-rendering context. So we can render in 2 different places. This is something I've been trying to wrap my head around for a while. And I feel like this week I made a bit of a discovery. So now that we've got our rendering on a texture, we can do stuff with it, like process it with more gen stuff. But what I want to do is use first some jit.gl.parses rendering to this node rather than the world. So I'm going to make a jit.gl. My God, can't spell. Jit.gl.parse. And the first effects I'm going to try FX name bloom-HQ, and I want this to render to the node, or rather use the node subcontext as the texture that it's going to process. Let's see if this works. So let's just put in the node and see if that's worked. So let's connect that to the video plane. Yes, 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 yes. Yes, it works. Yes. Oh, celebration guzzle. Right. Okay, so now what I can do is I can use pass processing on this node, which is rendering all of this stuff to the final render context, which is the world. So if I go to right click the input, the threshold is the only one really I want. So let's bring this up a little bit. If I pull this down, not really happening. I wonder why. Is that really happening? I can't tell. No, that didn't work. Do I need to tell it to capture? Let's try capture 1. No, didn't like that. Let's go to the help file. Right, they've done it here. jit.gl.node pass ctx. Right, so that's pass context. So that's the final. So the node is rendering to that, and this is rendering to. They've gone into a layer. At name. Yeah, that's what I've done. World at name the node pass the node. That's what I've done. Why isn't it working? This is bullshit. All right, they've done it with a layer. Let's try layer jit.gl.layer. See what that's given us. Yeah, it's not really happening. Not giving me much bloom. Oh, there we go. Yes, it is. There we go. Okay, I think maybe I just needed to have the threshold. Let's put the video back in. jit.gl. Oh my God, video plane at transform reset to, and see what that's like. Yeah, that's bloomy. Nice. Some of those frequencies are a little bit high. Let's maybe try like 50 here, 100 here, and 125 here. Very glitchy. Okay, so we've got our pass processing texture now here. So we can do some processing on this texture. We can add more passes if we want. Why don't we do that? Let's try jit.gl.parse at effects name DOF, which is depth of field, and connect the middle outlet of the first one to this one. Let's see if that's worked. It's very hard to tell. Yeah, the bloom's working. So what DOF does, it does depth of field. So we've got some parameters in here. What have we got? We've got blur width, and we've got focal range. Let's put it all the way over there. Focal distance. Right. So So the focal range is how much it's going to be in focus. The distance is where in space it's going to focus on. And the blur width is how much blur we get. So let's see if we can get this working. So you can see now that it's kind of out of focus. If I set the range to 1 and the focal distance to 3, okay, we're going to have to sort of tinker with this. Maybe if I go in a little closer, scale it down a little bit more, see if we can find... This is happening so fast, it's kind of hard to actually see. Can't actually tell. So that's obviously pretty out of focus. As we get closer, it'll be kind of in focus. Now, you know what? I never really have... I think it's because we don't have a material. Yes, no. This will only work if you have a material. All right, let's make a material. Let's make a jit.gl.material and just connect it to our grid shape here. I wonder if that means if we're going to lose the color scheme. Right, focal range of 1. Let's try the distance at 3. Zoom in a little bit. Focal range of 0, or distance rather. You know what? I'm binning it off. Goodbye, depth of field. We'll try again another time. So, that was a bit of a failure. Oh well. We don't get upset about things like that on Ned Rush. Okay, so we can do a little bit of stylization by now that we've got like our texture, our rendering node. I don't know what it is. It's render contexts within worlds. We can do a little bit of stylization on the texture. So actually, let's take somewhere here. There's this thing called separator. There it is. So this is just like a really quick and useful Visi thing that will allow us to sort of split out the RGB channels of a texture. So we can kind of give it a little bit of stylization. If I sort of shift the red a tiny little bit, we get, yeah. You can sort of, obviously, yeah, we can kind of give it like a bit of a vibe. I'm gonna bin off that. Oh my. Okay, let's maybe oh, you know what? That looks fine as it is. Okay, so yeah, as I was saying, now that we're rendering, that we're using a node for a subcontext render, we've now got that on a texture. We can kind of do some other stuff. We can process the scene like as a texture. So we could do something like jit.gl.bfg at basis input dot distorted. There. Okay, now we're kind of distorting that whole image. We could use some things here. We can increase the zoom. and we could decrease the distortion to a very small number, something like 0.01. Let's bring the zoom up like way high. There we go. 30. So yeah, we just kind of added like a bit of noise to the image, I suppose. We can go to inner basses now and choose what we want. We could have cell, so it's more sort of like glitchy, broken TV type thing. Yeah, that's nice. Let's try a really small amount of 001. Yeah, there we go. So it's just a little bit of stylization on the final image, you know. All right, let's go transform. Blah 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 blah. Yeah, that'll do. You can obviously, you know, try other things. Try some Visi modules, or if you've got a gen patch that works on textures that you like, you can try that. Anyway, that's kind of really it. Okay, let's set draw to the node. Yeah, that's all looking pretty good. I think that's pretty much all I want to cover. Okay, that'll do. Where's the transport? Yeah, let's stop the transport. Okay, so let's have a little recap. jit.gl.gridshape with matrix output going into jit.gl.multiple and then into another grid shape to give us our shape, our plane of a multiple array of cubes. Jit.catch is doing the audio analysis, and then we wrote a little gen patch to convert it from like a load of lines into some circles. That then goes into the Z axis of the three-dimensional matrix being spat out by this grid shape, so that we can flex the Z axis according to the shape of the jit.catch, which is analyzing the audio, and we've done a load of stuff over there. There we go. Okay, so I'm going to go and put this on my Patreon now, and you'll be able to download it and play around with it and do whatever you want with it. I don't care. And for all of you who are already there, thanks for supporting me, and that your membership is valuable. I could not live without it. And if you're joining now because of this video, hello! Okay, and now goodbye. See you next time.